Hey everybody, it's Mr. N here, and we are going to do the grazing goat example. You will have an activity like this that you'll need to do on your own, but let's just do this one together so you can kind of get a feel for what's going on. And going ahead and reading the problem, it says, Mr. N's goat, Kobe, is tied to a barn at point B shown in the diagram. Mr. N doesn't want Kobe to overeat, so he limits his grazing area by changing the length of the rope. Okay, so his goat, G-O-A-T, you get what I did there? G-O-A-T, Kobe, goat, Kobe. Okay, anyway, so let's see what we got. We've got this rope that's 5 feet long, and it's tied to point B right there. And so basically 5 feet long, so Kobe can go this way, can go that way, and around like that. What am I forming there? I'm forming this circle, but am I forming a full circle? No. It stops right here, can go to here, and then go like that. So I'm forming 3/4 of a circle that has a radius of 5. So let's write down what we got. So we know that we will have a grazing area, and the area is a circle, pi r squared. We know the r is 5, but we only need 3/4 of the circle. So we write this as the area, the grazing area will be 3/4 times pi times 5 squared. So that will give me 75 pi over 4. And you can change this to a decimal. 75 times 3.14 divided by 4. But for the sake of time in this problem, I'm just going to leave it like this. That's 75 pi over 4 square feet. All right, let's move on to the second example. And on this one, it says the rope is 10 feet long. So let's see if we can adjust this and make Kobe's rope 10 foot. So look what happens. 10 foot, that's 10 feet. So 10 foot means I'm going to hit the top right there. 10 feet, I'll go this way. And, oh, what happens when I get there? It changes something. It hits this corner, and it changes. It kind of bends around that corner. So we know that this will be 10 right there, up to the top, down to here. And then when I get to this point, something different happens. I end up with a completely different radius. So I will end up with something that is now 5 feet, and this radius, this is 5, because that's 15. So that will go like that. So I end up with this, because we said it goes all the way to the top, it goes out like that, and 10 right here. So you'll have that, I can't really draw it too well, but like that. So you'll have 3/4 of a circle in here, and then the 1/4 right there with a different radius. So you will have 3/4 with radius equaling 10 and 1/4 with a radius equaling 5. So we can write this as the area will be 3/4 pi times 10 squared plus 1/4 pi times 5 squared. Well, that's going to be 300 pi over 4. This will be 25 pi over 4. So the total grazing area will be 325 pi over 4, and that will be square feet. And again, yes, you can change this to a decimal as you please. All right, so let's move on to part C and take a look at what that problem says. Okay, and it says, if the rope is 20 feet long, what is Kobe's grazing area? So now we're looking at a 20-foot long rope, and let's see if we can draw this out and determine what it would look like. Let me erase all this stuff right here first. And let's take a look at what we have. And if I can extend the current one out here, I may not be able to. I may have to draw a new one. So we have at point B, we've got the new radius, and let's get that on there. And this new radius, though, let's put it in another color, see if we can do it. There we go. is 20 feet. So here's what this means. I'll be able to go, since that's 20 feet, that's 10, I'll be able to go all the way to the end here. And then I'll have this circular pattern that goes like that. So let's draw that in right now. So I will have this circular pattern, and it hits somewhere right there. We don't know yet. We can find that out in a little bit. Okay, then coming back to our situation, Kobe will be able to graze all of this in here. And then over here, 20 feet again, right? So that's 20, this is 40, so that means this is 20 to the end. And then that same circular pattern. In fact, it's the same exact thing as on the other side, because if you take a look, I'm just going to draw, I am just going to draw this right here, up, and if you look at this, this is 20 by 10 on this side, right here. It is 20 by 10, so this will be 20 by 10 as well, because the whole thing is 40 across. So what ends up happening is you get the same exact situation on this side, and it's just a reflection of the other side. So you get this portion of the circle when this comes around right here, up and out, right? So if I just find one of these, and I will go ahead and, let me move this out of the way a little bit, and I'm going to draw this in and say that this, like that, is my 20-foot radius, right? And it'll be 20 feet out to here as well. I'm going to call this one Region 1. And I will kind of do this type of thing. I'll call it Region A. Let's do that. This I will call Region B, which will be equal to Region A, because it's just a reflection of itself. Okay. Now let's take a look at what else we have going on here. So if I extend this out, and let me get this tool back. So we've got 20-foot radius right here. So this whole barn is 20 feet. So it's really going to be right down to here like that, right? I can create another region in here until I get to this point where I have a corner, and it'll change the radius again. So I've got this other region in here that goes like that, and I'll call that Region C. And the reason I'm breaking up these regions is I'm going to find each area separately as a separate problem, then add them all up. That's the easiest way to do it. There's not just one formula that'll do the whole thing. So now what happens is it changes this radius when you hit this corner, and now you get a new radius of 15. Well, this is 15 right here as well, right? When it hits this corner, it's going to change it again, and you'll have another, let's change the color on it again. You'll have another now radius, right, where this is going to go to here like that. Some sort of situation where it'll go to here. And let's draw that in, and this will have a radius of 15, right? We know that. And it'll look something like this, that part of the circle. So I'm going to call this one Region D, and I'll call this one Region E up here. Okay, so those are the different regions that we're dealing with, and let's see what we can do on this problem. So let's scroll back down and take a look. Okay, it says, if the rope is 20 feet long, what is Kobe's grazing area? We divide it up into regions, and instead of scrolling back and forth, I'm just going to kind of redraw each region over here so you can kind of see it. So let's do this first one. Let's do Region 1. So for Region A, that's what I should call it, Region A, we had this thing going on, remember? And this was a radius of 20, and we had the arc in here, and we had some sort of distance right there. I'll show you one more time real quick. Right there, that's what it would look like, where Region A was. So let's continue on with that. And this right here was 10, and this was 20, right? Because it's the same as this radius right there. This is a right angle, and I need to figure out how to find this area. Well, the first thing I need to know is I need to know what these angles are in here and in there. For the sector, the circle, that one's going to be very difficult to determine what the angle is going to be. But for the triangle, we can do it. On the triangle, we know that if I use the cosine, and I can call this like a theta, that's going to be the adjacent over the hypotenuse, so that'll be 10 over 20. So that means theta will be the inverse cosine of 10 over 20, and theta will end up being 60 degrees. I used it on my calculator to figure that out. So this angle in here is 60 degrees, which means that angle right there will be 30 degrees, because we said 90 minus 60. All right, so now we've got the sector of the circle. So I can find the area of the sector, and that's going to be a radius of 20, right? And we have our angle is 30 degrees. So we could say the area equals 30 out of the whole 360 of a circle times pi times the radius squared. So that area ends up being 33.33 pi, and I'm going to change this to a decimal, and that's going to be 104.67 square feet. Well, guess what? With region B. Well, I'm not done. I'm not quite done yet because I need to know what this triangle is, and then I'll talk about region B. So here's what I'm saying is I need to know what this triangle is in here. So I found this area, and let's shade it in. I found this one, but now I need to find what this one is right in there. And that triangle, the triangle is going to be 1/2 times the base times the height, which is 1/2 times, this base is 10, but how do I get this height right here? Well, I'm going to have to use the Pythagorean theorem. Okay, so I'm going to have to say that this piece right in here is going to be a squared plus b squared equals c squared. And so that'll be 20 squared minus 10 squared equals, we'll call that x squared. Solve for that, you're going to get 400 minus 100, the square root of that, right? And that'll be the square root of 300, which will be 10 root 3, but we're going to keep it as a decimal. So we're going to say 400 minus 100 equals x squared, and I'll just do it right here. X will end up being approximately, that's going to be, I'm going to keep everything as decimals, which is 17.32. So we're going to put this times 17.32. So the area of the triangle ends up being 86.6 square feet. So add these two together, and you're going to get 191. I'm adding, just in case you're wondering, I'm adding the 104 and the 86. You'll get 191.26 square feet. Now I'm going to keep track of everything right here. I will do it in another color so you guys can see, and we'll say region A, we got 191.26. Region B will be exactly the same as region A, because we said these are all square feet, because we said it's just a reflection of itself. So let's see if I can show you that. So right there, it's just a reflection of itself, right? So region A and region B are going to be identical. All right, let's move on to region C. Region C was that quarter of a circle right in here. So if you take a look, region C was just a quarter of a circle that had a radius of 20. That one's easy. So let's do that one down here. And we will say region C is going to be, we said, a quarter of a circle, oops, 1/4, with radius 20. So the area equals 1/4 pi times 20 squared. And we work this whole thing out, and this is going to be 400 divided by 4, it'll be 100 pi, which is approximately 314 square feet. All right, so let's put that right here. This is region C, 314 square feet. See how I'm doing everything separately and trying to keep track of everything. All right, now moving on, we have region D. Do you remember what region D we called that? We called that this sector of a circle right here with a radius of 15. So I'm looking right here. Region D was this part of a circle with radius 15, but I don't know what that angle is. I do know that this side length right there, well, if that's 20 and that's 15, I know that this side length is, oops, I don't know what just happened, but I do know that this side length is going to be 5, right? And so I have a triangle here that's got this hypotenuse is 15 and that's 5. It's kind of like what we did up there. I'm going to have to solve for those angles. So I'm going to draw this down here, and we'll calculate it down here. So region D was kind of like this pie-shaped region that looked like this sector that looked like this, right? And we said that this was 15, this was 15, and I need this angle right in here. But I knew the other side of it, like that, which was this triangle, and this piece right here was 5. So I have this triangle, I'm going to take that out, where this is 5, this is 15, and I'll call this y. All right, so I can get this angle just like I did up above, and I'm going to use the cosine of theta, and this time it'll be 5 over 15, right? If I use this angle adjacent over the hypotenuse, and that means theta will be the inverse cosine of 5 over 15, and that comes out to be approximately 70.53 degrees. So that means this angle right here is 70.53 degrees, and then it would leave me with this angle in here as being 90 minus 70.53, which would be 19.47 degrees. Okay, so now let's find region D. Region D, the area will be, this was 19.47 degrees out of the full 360, right? It's the part over the whole. It's this part over the full circle that I would have here going all the way around. So part over whole times pi times this radius that we had, 15 squared. All right, this, when all is said and done, comes out to be 38.21 square feet. All right. Now, we need region E. Let me do this in another color so we don't get it confused. We need region E, and we had this triangle this time, right? So this was 15, this was 5. I needed to solve for y right here. Y will be the square root of 15 squared minus 5 squared, right? Because 5 squared plus y squared equals 15 squared, Pythagorean theorem. 5 squared plus the y squared equals 15 squared. Solve it. I know you guys can do that. So y ends up being 225 minus 25, 200, so that'll be 10 root 2. So that's approximately 14.4. So the area will be 1/2 that base length, which we just said is 14.14, times its height, which is 5. So the area here comes out to be 35.35 square feet. All right, let's write these in to what we have above. We have region D, and we said that was an area of 38.21 square feet, and region E, which we said was 35.35 square feet. Now we add all these together, so we get the total. Adding A, B, C, D, E together is going to end up being 770.08 square feet. And that is the solution to this part of the problem where the rope was 20 feet long. Now, I could do a lot of things with these problems. I don't have to have Kobe right here at point B. Let's get this tool in here. I don't have to have Kobe at point B. I could have put Kobe initially at point A. I could have put Kobe initially down here at point C, even at point D. So it all changes. Put Kobe down here. It all changes depending on where the rope is tied and then how that circular pattern can happen. All right, so this was a tough one, but thanks for watching. Hopefully this will help you with the problem you have to do. Make sure you hit that like and subscribe button, and I will see you guys in the next video.